Hello and welcome to my YouTube channel Civil Line. Myself Milan Patel, Assistant Professor at LJIET Institute of Engineering and Technology. Today's topic is Civil Engineering Materials. This is the 8th lecture of this topic. In previous lecture, lecture number 7, we have discussed two materials, bitumen and various smart materials. In today's lecture, we will discuss first optical fiber, second pipes, third wire and cable, and lastly we will cover FRP, which is fiber reinforced plastic. Okay, so without wasting much time, let's begin with optical fiber. In this material, first we will discuss what is optical fiber, what is the structure of optical fiber, what is the working principle of optical fiber, classification of optical fiber, and various applications of optical fiber. Let's start with what is optical fiber. Okay, an optical fiber is a hair-thin cylindrical fiber of glass or any transparent dielectric medium like this. Okay, the fiber which are used for optical communication are wave guides made of transparent dielectrics. Its function is to guide visible and infrared light over long distance. It is the medium in which communication signals are transmitted from one end to other end in the form of light. The signals are digital pulses of light representing the information. The information which are passing through optical fiber can be voice information, data information, computer information, and video information. The advantages of optical fiber compared to another cable or fiber are it can transport information to long distance in lesser time. It is unaffected by interference of electromagnetic radiation. Okay, these are the two main advantages of this optical fiber. Okay, now let's discuss the structure of optical fiber. How this optical fiber is made. Okay, it is a long thin strand of clear material. Okay, its shape is similar to cylindrical. Okay, in the center part it has a core. You can clearly see the core part. Okay, around the core there is called a cladding is there. Light can travel inside the core and bounce off from the cladding. Okay, one plastic coating called buffer coating covers the cladding to protect it. Okay, buffered fiber is put inside an even tougher layer which is called as jacket. Okay, you can clearly see the jacket part. So this is the structure of optical fiber. Okay, now let's discuss the working principle of optical fiber. How this optical fiber is worked out. Okay, it is worked on the principle of total internal reflection, TIR. Okay, when a ray of light travels from a denser to rarer medium such that the angle of incidence is greater than the critical angle, the ray reflects back into the same medium. This phenomenon is called as total internal reflection. Okay, in the optical fiber, the rays undergo repeated total number of reflection until it emerges out of the other end of the fiber, even if the fiber is bent. Okay, this is how the information is passed through optical fiber. Okay, now let's discuss the classification of optical fiber. First type is single mode optical fiber. It transmits only one mode of light. You can clearly see the single mode optical fiber. It has smaller core diameter. The example of single mode optical fiber is telecom and community antenna televisions. Okay. Second type of optical fiber is multi-mode optical fiber. It transmits multiple modes of lights like this. Okay, it has thicker core diameter compared to the single mode optical fiber. The example of multi-mode optical fiber is local area network. Okay, this multi-mode optical fiber is further divided into two types: step index multi-mode optical fiber and graded index multi-mode optical fiber. Let's discuss the difference between step index and graded index multi-mode optical fiber. In step index multi-mode optical fiber, the refractive index of the core is uniform throughout and it undergoes an abrupt change at the core cladding boundary. Okay, while in graded index multimode optical fiber, the refractive index of the core is made to vary gradually such that it is maximum at the center part and minimum at the cladding part. Okay, in step index fiber, the diameter of the core is about 50 to 200 micrometer in case of multi-mode fiber and 10 micrometer in case of single mode fiber. In gradient index fiber, the diameter of the core is about 50 micrometer in case of multi-mode fiber. Okay, the path of light in step index multi-mode fiber is in zigzag manner. You can clearly see in this figure also the light passes in zigzag manner. Okay, because of the refractive index is uniform throughout the core. Okay, while in graded index multimode optical fiber, the path of light is helical in nature because refractive index of the core is gradually decreases from center of the core to the cladding. Okay, so light passes in the helical manners like this. Okay, this is the difference between step index multimode optical fiber and graded index multimode optical fiber. Now let's discuss the applications of optical fiber. First, it is used in long distance communication to send telephone and internet signals between two cities. Okay, it is used in shorter links also to carry out the sound signals between a compact disc player or CD player or DVD player and a stereo receiver or a speaker. Okay, it is used as a sensor in number of medical instruments. It is used to carry light for humans to see like fiber optic, okay, or Christmas trees. It is used to make endoscope or fiberscope. Okay, it is also used as optical amplifiers. Okay, and lastly, it is used in mechanical, surgical, military, and industrial applications. Okay, so these are the various applications of optical fiber where this optical fiber is used. Okay, that's all about the material of optical fiber. Now let's discuss the second material in today's lecture, which is pipe. In this material, first we will discuss the introduction and then we will discuss various types of pipes. First we will discuss the introduction. You all have seen pipe in your life. It is a circular closed conduit through which water or some liquid may flow either under gravity or under pressure. Okay, when pipes do not run full, they run partially under gravity, such as in sewer lines. Okay, however, in full supply, pipe mostly run under the pressure. Okay, let's see various types of pipes. First type is cast iron pipe or CIE pipes. Okay, this is the figure of CIE pipe. It is most commonly used in water distribution system. It is cheaper in cost compared to other pipes. It has high corrosion resistance, high durability compared to other pipes. It can damage during transportation also. Okay, it is available in 3 to 6 meter length. Okay, the drawback of these CIE pipes are rust and corrode problems. Okay, it can rust and corrode very fast compared to other pipes. Okay, second type of pipe is wrought iron pipes. Okay, it is manufactured by rolling flat plates of wrought iron and welding the edges between them. So there is a flat plate is there. If we roll this plate and weld it, wrought iron pipes can be made. Okay, it is lighter than the cast iron pipe. It can be easily cut, threaded and worked out. Okay, it is corroded very quickly and it is only used within the buildings because it is corroded very quickly. Okay, third type of pipe is galvanized iron or GI pipes. Okay, when wrought iron pipes are protected by one coating with thin film of molten zinc, it is called a GI pipe. So in wrought iron pipe, one layer is added, which is a zinc layer. Okay, it is called as galvanized iron pipes. They are jointed by screwed or socketed joints like this. It is available in light, medium and heavy grades. Depends on the thickness of the metal. Okay. Fourth type of pipe is steel pipe. Okay, this is the image of steel pipe. Steel pipes are made of solid steel of small diameters. Larger size are made by riveting or welding the edges of these steel plates or suitably curved plates. Okay, it cannot resist high external pressure, and these pipes are more useful above ground because below ground there is a soil pressure is there. Okay, and cannot resist the external pressure. Okay, so it is mainly used above ground operations. Okay. Fifth type of pipe is copper pipe. This is a copper pipe. It is mainly used in hot water installation. It has high tensile strength compared to other pipes. They have thin walls and can be bent easily. Okay, it is very costly pipe compared to other pipes. Okay, it is mainly used in water heater or in AC. Okay, next type of pipe is plastic pipe. It is used for supply of cold water in external and plumbing work also. It is light in weight. Okay, it is non-corrosive material. It has lower cost. It does not require threading in connection. Okay, it is made of synthetic resins of high molecular weight, polymerized by heat, pressure, and catalyst. Okay, this is called as the plastic pipe. Okay, it is light in weight, lower in cost, and mainly used for cold water application in external as well as internal work. Okay. Seventh type of pipe is concrete pipe. It is made of reinforced, unreinforced, or pre-stressed concrete. Mainly, unreinforced pipe are for smaller diameters. Okay, while reinforced or pre-stressed concrete pipes are used for larger diameters. These concrete pipes are used in water supply and for drainage line of rainwater. Okay, these concrete pipes are jointed by butt end joints. Okay, it is made by spinning process. Okay, that's all about the concrete pipe. Next is asbestos pipe. It is manufactured from asbestos fibers and upward cement. It is manufactured under pressure to form homogeneous structures like this. Okay, the joint in these pipes are of simplex type like this. Okay, it is generally used for drainage of rainwater from roof as a soil pipe, waste pipe, and also used for ventilation pipe. Okay. And the last type of pipe is lead pipe. It is soft and easily bent. It has high corrosion resistance compared to the other pipes. Okay, it has high flexibility also. It is not used in water supply because lead is poisonous to the health. Okay, it is not suitable for conveying acid water. Okay, it is generally used for apparatus required for alum and chlorine in number of industries because it has high hydraulic coefficient of flow. Okay, that's all about various types of pipes. Now, let's discuss the third material in today's lecture, which is wire and cable. Let's discuss the difference between wire and cable. Wire is a single conductor material, while cable is a group of two or more conductors. Okay, the wire is usually visible, okay, from outside, while cable is mostly the insulated material. Okay, it is covered by insulation materials. There are two types of wires, solid wires and stranded wires. The solid wire is made by only one wire like this, while stranded wires are made of number of wires in one package. Okay? Cable is of four types. First is twisted pair cables, where number of wires are twisted like this. Okay. Second is multi-conductor cable, okay, like this, in which number of conductors cables are there. Third is coaxial cable. It looks like this, one type of cable which is used in television. Okay. And fourth is fiber cable. Okay, there is a fiber optical cable which has the conductors of glasses like this. Now let's see the advantages of wire and cable. Okay, solid wires offers low resistance, thus perfect for use in high frequencies, while stranded wires offer high resistance to metal fatigue. Okay, while cable has high strength, heavy duty material, and also insulated from the various environmental effects. Okay, now discuss the uses of wire and cable. This wire allow mechanical loads on it. It can carry electricity and telecommunication signals. Okay, it is used in heating, jewelry, clothing, mesh, automotive, or industrial manufacture parts. Okay, while cable allow power transmission, it also carry electricity and telecommunication signals. Okay, so for power transmission, cable can be used for basic electrical work. Okay, or electricity or telecommunication signals, wires can be used. Okay, for long distance telecommunication transmission, cables can be used. So this is the difference between wire and cable. Okay, now let's discuss the fourth material in today's lecture, which is FRP, in which first we will discuss what is FRP, various characteristics of FRP, and lastly we will discuss their uses. Okay, let's discuss what is FRP. This is the FRP sheet. Okay, FRP is called as fiber reinforced plastic or fiber reinforced polymer. Okay, it is a composite of polymer matrix reinforced with number of fibers. The example of this FRP are first GFRP, which is called as glass fiber reinforced polymer. Okay, second is CFRP, is called as carbon fiber reinforced polymer. Third is aramid. Fourth is basalt. These are the four examples of FRP nowadays used in number of construction industries. Okay, it consists thermosetting resins and various fiber classes. Okay, resin is used for environmental and chemical resistance to the product. Okay, it is also used to bind glass fiber in structural laminate. Okay, that's all about the FRP. Now let's see the characteristics or the properties of FRP. It has good mechanical strength. It has good corrosion resistance. It is light in weight. It has excellent temperature resistance. It offers thermal insulation. It can be formed in complex shapes. Okay. It is easy to repair and require less maintenance. It is ideal for on-site installation. It has high tensile strength compared to other materials, and it has high heat stability. Okay, these are the various properties for which this FRP material is nowadays popular for repair as well as rehabilitation work in construction industries. Okay, now let's discuss its uses. It is generally used to strengthen or to repair or to rehabilitate the beams, columns and slabs of the building as well as for bridges. Okay, here you can clearly see the black sheet is of FRP. Okay, it is also used in roof sheets, doors, windows, frames, internal partition, wall paneling, concrete shuttering, structural section, water storage tanks, temporary shelters, etc. Here you can clearly see the green sheet is of FRP. Okay, it is also used to prepare FRP chairs and benches used for auditoriums, theaters, hotels, restaurants, lounges, waiting rooms, etc. Okay, FRP products of plasticon used in number of industries for processing of chemicals. Here in blue color you can see the plasticon material which transmit number of chemicals through it. Okay, these are the various major uses of the FRP. That's all about the material FRP. Okay, I hope you all understand this four material: optical fiber, pipes, wire and cable, and FRP. That's all about the chapter civil engineering material. See you soon in the next lectures. Thank you for watching. Don't forget to like, share and subscribe to my YouTube channel Civil Line. Thank you.